Okay, so we're ready to start again. I have to say, so far I'm impressed by the speaker and the audience. Everybody's on time. That's pretty good. So the rest of the day is going to be one session with Peter Krey, which I will introduce in a few minutes, to discuss how SDN and OpenFlow is adopted and how it can change the way the financial industry is running their network today. And after Peter, I will ask all the speakers that you heard throughout the day to come back, and I will ask them a couple of questions about what is happening into this space, what trends they see coming in the coming year. So for now, let's start with Peter, who actually, get through a lot of trouble to come here today, and he was keeping me updated minute by minute, but I'm so glad he made it, because we had a lot of questions about enterprises outside of carriers. How do they adopt the technology? Peter has a fantastic experience, more than 25 years in this industry. He is the president and founder of Krey Associated, which is a technology company, and he's helping, a variety and a lot of Wall Street CIOs and CTOs and early stage technology companies to define what their strategy is going to be from a research and an engineering perspective, as well as developing proof of concept and helping them adopt new technology trends and business development opportunities, which is exactly where SDN and OpenFlow is today. He's been the managing director and chief technology architect and CTO as a Deutsche Bank Asset Management, and the VP of business development and strategic partnering for storage virtualization companies such as Storage Apps, who was sold to HP in 2001, and has had various serious management technology in position at Morgan & Stanley and JP Morgan. So you can see a lot of financial and networking background, which will make today's session even more interesting. So thank you so much, Peter, for coming, and look forward to your presentation.
Thank you. Thank you. I'm really nervous now. I have to live up to that introduction. So, okay. Well, good afternoon, everyone. Very nice to meet everybody. Title here, usually we run the theme music for Curb Your Enthusiasm, but we couldn't do that, so we can kind of just have that running in the background as we're doing this. I'm going to apologize in advance. In order to do this presentation in 30 minutes, I'm going to have to average like a minute or so each slide. So I'm going to read through the speaker notes kind of like a little fast, but hopefully it'll still make sense and be coherent for everybody. I just want to say thank you to everyone, for the organizers of ONS. It's an honor for me to be speaking here at the second summit. It's been great. What we're going to go through is a couple of things. I'm going to tell you about who I am, why I do what I do. We're going to look at things in perspective from financial services and from using cloud as what I call the point of view, or the trying to do enterprise cloud internally, and what the ripple effect of that is in terms of automation, including the network. We're also going to take a look at some stuff around metrics. We worked on a grid or a spreadsheet trying to depict ways to measure and talk about enterprise cloud with folks that's interested in grid. And also a wisecrack I have called the New Grand Canyon, so I'll let you kind of wait for that one. Networking infrastructure as code, borrowing from the guys at Opscode, guys that wrote Chef, tons and tons of automation. I'm also going to go through a litany of OpenFlow-enabled open source applications and developer tools. And at the end, we're going to talk about how this is potentially, all this automation and all this standardization could have massive impact on operating expense and CapEx. I have to tell you right now, in financial services, those are the two most important things that keep everybody up at night right now. Okay, so I apologize. We're going to try to do the 30 slides in 30 minutes. Here we go. Okay, so who is Krey? Well, in order to set the tone and the core messaging of my presentation, let me begin with some background information about who I am. Been an independent consultant for about 9 years. Previously 25 years of core enterprise infrastructure engineering and application infrastructure within financial services, all the way up to a CTO role and head of architecture, reporting to various levels of CIOs of entire firms, CIOs of lines of business, etc. Majority of my clients are enterprise CIOs and CTOs and their direct reporting teams. On occasion, I get very lucky and get to help VCs and private investors, and my two favorites are serial entrepreneurs and startups. I'm constantly on the hunt for emerging disruptors and innovation to save. Innovating just for the sake of science projects or innovating just for the sake of innovating is a loser. Innovating to save is really the key. The concept and influence of open, in my opinion, rocks, whether it's open source hardware or open source software. The fact that it's open is huge. I'm a big fan and participant in things including Open Compute and OpenStack. I focus exclusively on thought leaders enabling disruptors, startup founding teams, only CTOs, heads of engineering, developers, engineers, those that actually create and make things. A key product of mine is the research, ID, and due diligence of disruptors and those thought leaders, creating tech strategy, hands-on prototyping, testing, etc., and delivery of working POCs. Not a PowerPoint jock or what I call a comic book artist, and even as old as I am, I strive to remain a hands-on technologist despite my age. A little bit of background. I've previously been part of teams that have built and delivered one of the largest x86 Linux HPC grids in financial services, lots of Hadoop-based big data POCs, and currently also working with a spectrum of clients on open source enterprise cloud projects. In a nutshell, I constantly scan the technology world on my Innovate to Save radar and my satellite system. So core focus today is not about super techie, low-level OpenFlow stuff, but a bit more about speaking to high-level CIO or CTO presentation about what OpenFlow can enable and how this innovation and how this has let the innovation genie out of the proprietary networking technology bottle. Okay, so here we go. We're going to begin today from the vantage point of cloud computing and asking everyone, okay, exactly what the heck is cloud computing? If you ask 10 enterprise technology people, you're likely to get 15 different answers. For external cloud, you'll hear SoftLayer, Amazon, Rackspace, Terramark, Verizon, Azure, and others. For internal cloud, you'll hear VMware, vBlock, or Acadia-based enterprise, what I call virtual machine farms, almost cloud. And for hybrid cloud, we hear all about OpenStack, especially the recent April 2012 Essex release, and since some industry thought leaders are also deploying. We've also heard lots about OpenStack now running and supported via collaborations with HP, Dell, and Canonical doing Ubuntu stuff behind the scenes. Overall, very poor signal-to-noise ratio around cloud on the commercial side, and one of the most over-marketed, distorted things in the enterprise tech world today. Kind of reminds me of the old days when object-oriented was the big buzz. It's analogous as a perception to the old Saturday Night Live joke, Shimmer. It's a floor wax and a dessert topping. It's also similar to the taste great, less filling Miller ads. But interestingly, out of all these graphs and all these charts, only one of the 6 is correct. Hopefully about in the midpoint of the presentation, it will be self-evident which one of these 6 is correct. Based upon my 25 years of enterprise experience, the following slide is the most succinct definition of cloud I've ever seen to date. Hope this comes across the right way. In a nutshell, the real answer is cloud is not a traditional enterprise IT. Per the upper right-hand corner, enterprise thinking around cloud is clearly the blind leading the blind. Upper right-hand corner cartoon includes some colleagues who've been disguised to protect their innocence. I can't really see. Whether internal or external, first time ever enterprise customers and developers have ever had choice, or what I call freedom and control. No IT people, no process, no bureaucracy, no business cases, no governance, no standards compliance, or 9 to 12 month process delay. While truly fully automated cloud, you get what you need in minutes, not months, and in many cases longer. Cloud is a dislocation of excessive process and delay, and potential traditional IT replacement versus 100% automation. Cloud has radically changed what enterprise customers expect is possible, how much it will cost, and how many minutes are required to get something done, not months. Also a huge enabler of many startups. A number of the companies I've visited, their largest IT staff has been 2. Most cases it's 1. And it's no longer a yes or no relationship with your customers, or we'll get back to you. It's now all about how fast, how cheap, and enabling them having freedom. So the big question is, what does this all have to do with networking? Actually, it has everything to do with networking. Just like open source, I'm a huge fan of the concepts embodied in DevToOps. Integrated DevToOps culture and automation removes the chuck-it-over-the-wall mentality and practices of the past few decades, and connects and integrates development with deployment and operations. Due to my visibility into both enterprise on the East Coast and West Coast technology and engineering operations, the above photos really resonate to me and characterize things. On the left, the enterprise East Coast approach really does feel very manual, time-consuming, overly complex, low-tech, antiquated, inconsistent, error-prone, very difficult to repeat at speed and scale. Traditional enterprise technologists are sometimes resistant to innovation, remain stuck on tier 1 enterprise commercial vendors and a traditional enterprise operational process. Including myself, we all used to suffer from what I call enterprise muscle memory. We've been repeating the same range of patterns and motions, aka process, for so many years, they're approaching being mentally handicapped, unable to leverage positive change and enabling innovation. Another wisecrack is if I were asked by a corporate psychoanalyst the left photo in a diagnostic Rorschach test and say, Peter, what does this photo remind you of? I would say it reminds me of my old days in enterprise IT. It also reminds me of a sarcastic wisecrack co-authored by a global CTO friend. This is true. Enterprise IT puts the no in innovation. That's a direct quote. It ain't funny. And if during the same session I was asked, Peter, what does the right photo remind you of? I'd answer West Coast startups, large-scale Web 2.0, Google, Facebook, Amazon, others. So that's why the left photo makes me think enterprise. Being of Yugoslavian heritage, I feel comfortable also seeing the left-hand shot analogous to the balkanization of enterprise IT. Sorry, Dad. In sharp contrast, West Coast feels highly automated, highly repeatable and consistent, highly receptive to adopting and advancing innovation. So lots of open source, standards-based, vendor-agnostic hardware, and tons of automation. So what does this have to do with networking? Again, it has everything. Good news is an emerging set of enterprise CIOs have realized that true cloud drivers represent opportunity, not challenge. Emerging and increasing self-awareness. IT really is indeed too darn slow. Excuse me. Very interesting, such a story makes the cover of Information Week back in October of 2011. And the cloud computing is all about 100% automation and self-service, 0% bureaucracy, process, and delay. An interesting example. I've heard through the industry grapevine that one of the individuals quoted here is way more engaged and impactful than his quote may indicate. So for example, in June 2001, using Opensource Chef tool, a company called Cycle Computing fully automated creation and provisioning of a protein analysis application on Amazon Web Services. In under 45 minutes, a 1,250 VM instance with 10,000 core compute and cloud storage being created decreased overall costs from the internal app of $5 million to $8,500, or about $1,000 an hour. In September 2011, they did a second phase of this in approximately 90 minutes with 3,800 virtual machines and 30,000 cores. Both are very impressive validation of what 100% automation can create and support our very large scale. I'm also hearing through the grapevine that some even bigger things will be announced really soon. So once again, what does IT is too darn slow have to do with networking? Well, again, tons. How does one establish consistency and fairness within the enterprise when defining and discussing cloud? Biggest issue is cutting through the vendor qualitative marketing noise and establishing a way more qualitative approach and metrics. Most traditional enterprise clouds are really just virtual machine farms, entrapped with traditional enterprise manual process and governance, and the significant cost premium being about 100% tier 1 vendor proprietary product. So one solution to getting everyone on the same page is to speak directly to developers and end users and ask them why they like external cloud computing so much. The above is a generic example of such an exercise. Interesting points. What are the degrees and completeness of automation? Exactly how repeatable and precise are the underlying processes? How long does it take to get something done? Minutes, hours, days, weeks, months? How much of the overall infrastructure provisioning and management is actually automated, and to what degree? And how do these all compare to external cloud providers such as SoftLayer, Amazon, Rackspace, etc., and the upcoming torrent of OpenStack external implementations? Once again, the question I keeps ringing at me when I look at these is, what does it have to do with networking? Tons. The above bullet points are a summary and synthesis of all the sources listed along the bottom page. A good mix of geek and business sources, such as The Economist. To make a long story short, the most popular and effective clouds are 100% self-service, 100% automated, vendor agnostic, open, and IT process free. The most popular are best depicted via what we call the Hertz Gold Rent-A-Car model. I go to a website with my credit card number, I book a reservation. When I go to the airport, I find my name on the Hertz Gold board, go to the parking lot spot, I get in, drive, and I'm done. Cloud-based VMs are handled almost exactly the same way. There's zero process and bureaucracy. Either a command line script or a few GUI clicks, I'm free to choose whatever car or VM that I want. And the other thing is it takes seconds to minutes, not months. Sysadmins and developers have autonomous command line interfaces or REST API access, language and tool independence. And these facilitate development of vendor-neutral automation. So the only thing between me and what I need now in terms of enterprise cloud are a minute or two and my credit card number. So again, this begs the question, what does it have to do with networking? Everything. This slide has way, way too much detail. I'm only going to spend about 15 seconds here. These items are a summary and synthesis of all the reference sources shown on the bottom, not from a vendor marketing slide deck. National Institutes of Standards, as a source, they're very frequently referenced, but I've also added a number of more non-traditional and business-oriented sources, including The Economist. Point here is that my focus today is at or below infrastructure as a service. And that's everything, and that everything else is what sits on top. So if you don't get this layer right, infrastructure as a service, everything above is impacted and suffers. Overall, lots of cloud thinking in terms of an OSI model or a stack, like the following slide. This matrix was from the OpenStack crew. It provides a very interesting comparative positioning of various external cloud offerings. Lots of Amazon AWS adoptions out there, great automation and command line tools, 100% self-service. To my eye, the ideal target basis for comparison. It also depicts that enterprise IT end users and developers are no longer imprisoned and now actually have choice. So if enterprise IT does not respond, we're going to be dinosaurs pretty soon. Reason for me going down this path is to ask everyone today, despite what looks like a thorough, comprehensive infrastructure as a service, platform as a service, and software as a service analysis of cloud, what key aspect is really missing here? Despite either point of view, whether it's dev to ops or the more OSI-like infrastructure as a service, network is clearly missing. How the heck can anybody enable all the 100% automation, 100% self-service, not enterprise IT, end user requirements without enabling automation and standardization of things down in the network layer? And how the heck can you enable applications, corresponding application infrastructure, storage, and to be free from static location-dependent configuration and implementation details without the same level of indirection and virtualization? And without enabling language-independent automation interfaces such as REST-based APIs, how can anything be automated in a vendor-neutral, standard-based way? So in summary, what the heck about the network? Well, to my eye right now, it's a giant gaping hole. And my wisecrack for it is, networking is the new Grand Canyon. From an automation standards, vendor-independent perspective, networking is the new Grand Canyon. The point of these four pictures is, no matter how you look at current thinking and closed proprietary technologies in enterprise networking, getting across this gap is extremely difficult, at best impossible. And in order to produce cloud automation, requires automated CLI or other developer API access to a minimum of 3 core components. The first is the server and the hypervisor. VMware has narrow and limited API access via SOAP, getting better, but it's still pretty closed. Xen Server so far has been very good. OpenCLI, XML, RPC, Python access. Just about all functionality is fully accessible. KVM, whether directly through the API or through something called Overt, developer tools and API access is becoming fully open. I think it has a very bright future. IBM, Dell, bunch of folks involved in contributing to the code base for KVM. And libvirt potentially provides a developer API that's hypervisor independent. Can't say the same thing about networking. Let's look at storage for a second. Traditional enterprise storage is very limited, non-existent or narrow APIs, traditionally closed proprietary functionality. For mountable open storage, there are things like Nexenta and Gluster. Ceph is coming. All have fairly open APIs and full functionality. And there's another category that's brand new for most East Coast developers, but is very, very in widely use out here out west, what we call distributed object stores and NoSQL technology. All of them have wide open developer API access via REST and command line tools. These include things like OpenStack Swift, Ceph, MongoDB, Cassandra, others. Accessing is no problem. Which leads me to the network. The functional developer gap is really the size of the Grand Canyon. To me, it's a huge problem. Very closed, very proprietary, very limited developer API access. In many cases, the state-of-the-art automation is copy-paste. Needs to get better. The historical rate of innovation is pretty close to zero. Core networking issues are not just about automation enabling developer access, but it's also the ability to isolate application and middleware layers from traditional network operations and configuration stickiness. Enterprise cloud is currently locked in due to lack of open standards, virtualization, or the Teflon of enterprise cloud. We need to isolate applications and middleware from static configuration issues and lack of mobility. Well, thankfully, there's OpenFlow. To me, by far one of the most interesting and emerging and potentially enabling network innovations in many years are the software side things of OpenFlow. Starting back in 2008 and 2009 as part of Stanford's Project Clean Slate program, with initial collaborative participation also by Princeton, Cal Berkeley, MIT, University of Washington, and Washington University St. Louis. Thanks very much to this group and to others. For them, we're here today. To my eye, the most impactful and disruptive aspect of OpenFlow is its hugely enabling open source software and potentially blasting through the Tier 1 networking Berlin Wall and enabling unrestricted open source software development. And yeah, it also enables a whole new genre of standards-based vendor-independent networking hardware as well. Heads up, genie's out of the bottle. Back in 2011, October 2011, InfoWeek ran a great article about OpenFlow. It was almost within the same week as the first summit. And the article included two quotes from two CTOs that have had strong efforts within OpenFlow, the OpenFlow open source community. Martin Casado is one of OpenFlow's developers and currently CTO of Nicira, and he's been seeing some pretty cool stuff built on OpenFlow. This includes network connectivity managed by high-level language that plugs into existing proprietary security frameworks. Martin's key points are that OpenFlow gives network managers programmatic control of their networks using industry standards, and I quote him, using the same distributed systems libraries and packages they use to orchestrate the rest of their infrastructure. And Kyle Foster, CTO and co-founder of Big Switch, stated that OpenFlow will make a lot of difficult networking problems easier to solve. And him I quote, OpenFlow gives network managers programmatic control of their networks using industry standards, using the same distributed systems libraries and packagings they use to orchestrate the rest of that infrastructure. Both Martin and Kyle are very sharp guys. So what is OpenFlow? In a nutshell, OpenFlow is a protocol for server software, aka the controller, to send instructions to OpenFlow-enabled switches. And these instructions give direct control over how these switches forward traffic through the network. Per Wikipedia, OpenFlow is a communications protocol that gives access to the forwarding plane of a network switch or router over the network. In simpler terms, OpenFlow allows the path of network packets through network switches to be determined by software running on a separate server. Some refer to this as the separation of the control plane from the data plane, where the control plane is implemented and driven by software, in this case, open source software. This separation of the control from forwarding allows for more sophisticated traffic management than feasible using access control lists and traditional routing protocols. And it also allows open development of software-based applications to run on top of OpenFlow-enabled infrastructure. To me, that's the most exciting point. OpenFlow is increasingly referred to as software-defined networking. Okay, to be fair, I'm not technically competent to stand here today, lecture and debate about the low-level pluses and minuses, technical capabilities and merits of OpenFlow. But what I can tell you is it hugely strikes me that about what OpenFlow makes possible and what it enables, not the hyper-low-level details of OpenFlow itself. I think of OpenFlow as an open version hardware layer for networking, kind of how ARM enables mobile and tablet technologies, except OpenFlow is fully open and accessible. Per the above, there are numerous and growing OpenFlow software switch options, numerous and growing OpenFlow physical and virtual hardware options, and numerous and growing OpenFlow controller options. And yeah, at the hardware and platform level, it's complex and powerful, but at a higher OS and resulting application layer, it's hugely enabling. Luckily, I've worked with and for enough talented developers, I can say, what the heck? There are how many open source software projects emerging that run on top of OpenFlow? And I've worked on enough enterprise HPC grid and cloud projects to testify that manual, people and process-oriented, non-automated proprietary network operations are extremely limiting and imprisoning. In a nutshell, OpenFlow is enabling an awesome batch of open source software-defined networks and developer tool projects. To me, it feels like the Shawshank-like escape from traditional Tier 1 enterprise networking, the networking model, from both the technology and operations perspectives. Not only enabling switching hardware independence, but also a growing range of software-defined network tools and open source projects. This is absolutely key. From the previous list, I've picked out a couple of examples to run through. Frenetic, as defined on Wikipedia, is a domain-specific language for programming OpenFlow networks, embedded or enshrouded in Python. A domain-specific programming language that allows network operators, rather than manually configuring each connected device, to program the network as a whole. Frenetic is designed to simplify OpenFlow, its programming and complexity challenges. In particular, Frenetic introduces a set of purely functional abstractions that enable modular program development, defines high-level, programmer-centric packet processing operators, and limits many of the difficulties of the two-tier programming model by introducing a see-every-packet programming paradigm. Hence, Frenetic is a functional, reactive programming language operating at a packet level of abstraction. Okay, with all that said, you mean I can do all that stuff in Python? To me, that's really amazing. As a developer, I may now be free getting from proprietary, closed, non-automatable, people and process-oriented confinement. And software developers can now share core functionalities of these pieces of code on things like GitHub. And now hundreds of amazing and innovative open source Python capabilities and modules can now also empower networking. That's big. You mean we can now all write some level and degree of vendor and silicon independent networking innovation, and we can be Python open sourced? That's pretty impressive. Okay, so if I'm not a Python developer and I need support for a more Java-oriented enabling OpenFlow platform, enter Beacon. The Beacon project claims to be a fast, cross-platform, modular, Java-based controller that supports both event-based and threaded operation. It's built on mature Java development frameworks such as Spring and Equinox, which is OSGI. It's jar WAR file based. Amazing. But hang on a second. Did they really leverage Java, Eclipse IDE, the Equinox OSGI app server model running Spring? These are things I've never seen inside of enterprise networks ever before. And are those OSGI models and Spring XML config files? To quote Mel Gibson from Braveheart, it cries freedom. Okay, but what else is supported? Knox, although pretty low level, for those who need OS level work and functionality, we have Knox. It's an open source OpenFlow controller, leverages the abstraction switch layer, aka a network operating system. Knox components can be written and complemented in C, C++, and Python, and integrated and leveraged together. The Knox C++ API integrates and leverages a toolkit called Boost. I'm not sure how many C++ developers there are in the audience, but that's, again, like Spring, the first time I've seen that kind of developer tool in the enterprise network. It's pretty impactful. Yet more amazing use of traditional software development tools for software-defined networks. So I'm going to pause for a second. Two colleagues, the founders of Opscode, what the heck does all OpenFlow, open source software, Python, Java, and C++ have to do with impacting the data center? Well, frankly, the impact is potentially huge and highly disruptive. It's a bullseye on my Innovate to Save radar and satellite system. It borrows heavily here from the two co-founders of Opscode and the authors of Chef. OpenFlow is a giant enabler of infrastructure as code, and in concert and collaboration with automation-enabling tools such as Chef and its underlying language, Ruby, the highly innovative world of open source software has finally been connected with the traditionally static and near zero rate of innovation that's been limiting to the traditional networking world. In my view, this is potentially huge. Finally, the rate of innovation and span of thought leadership that can empower the networking world with these tools is potentially unlimited. To further borrow from another industry thought leader, James Hamilton of Amazon, networking is about to become the new mainframe. So borrowing from the guys at Opscode, I now look at network infrastructure as code as potentially very disruptive. By enabling an open, standards-based OpenFlow, software, not hardware control plane, networking innovation can now leverage, enabling a series of very powerful capabilities analogous to software version management and bill of materials or BOM dependency analysis. Translating and applying software development tools, version control, build management, and other methodologies to network functional descriptions. From a developer's perspective, generating and managing infrastructure configs and state management analogous to application build and version control. Imagine actually having an x.y.z type source version control and dependency management metadata about your network, and creating a 100% repeatable automation process with tools like Chef. So in comparison to server configuration management, hypervisor developer tool access, and open storage API access, enterprise networking is the new Grand Canyon. The gaps are potentially huge. And it very, very badly needs to evolve and develop. It's traditionally been innovation starved. Apologies for the bad eye candy here, but I'm trying to get an idea across. The idea is that OpenFlow is a fundamentally enabling connection between the two previously separate and unfamiliar worlds. From my perspective, OpenFlow can also be viewed as a periodic table for networking. So analogous to chemistry, it's impossible to fully anticipate the expected total combinations of individual elements or software-enabled components into networking compounds that can emerge over time. The key message here is to highlight this: for the first time, two previously separated technology worlds are finally been connected and potentially enable a multiplicative generation of innovation. For example, when Python became mainstream some years back, did any of us envisage OpenStack or any of the large-scale functionality at Google? It's pretty impressive. And when Java first hit the enterprise developer back in the mid-1990s, did anyone envisage a Java-based big data innovation such as Hadoop, developer frameworks such as Spring, and WAR file-based app server models such as OSGI? To my eye, OpenFlow may also enable a whole new genre of hybrid capabilities among these, being the connector among these two worlds. For example, a Java JVM-enabled language such as Java and Python via Jython, Java and Ruby via JRuby, JavaScripting via Groovy, and a new generation of Java-based languages, Java VM-based languages, such as Scala, Clojure, and others. As a sidebar, I added a small OpenStack logo down on the bottom of the slide. Reason for this is I'd like to see more formal integration and collaboration with OpenStack and OpenStack with ONS. Yes, I am aware of Open vSwitch and Quantum at the NIC level, at the hypervisor level. So what I'd like to see is more and more about how OpenFlow and OpenStack are collaborating at the switch and broader networking level. And if anyone in the audience knows more about this, please come up at the end of the session and tell me. I'd really like to talk about this. And thinking like an ex-HPC grid computing geek, given a cloud of guest OS VMs, I'd also like to see Monte Carlo-like software simulations of SDN-created configs prior to deployment. It would be great to stress test stuff before they actually deploy, and you got to use them. So in a nutshell, describing and capturing network infrastructure as code, the OpenFlow application layer is potentially very, very disruptive. Okay, switch a little bit over to hardware. The other massive vector of disruptive force here is on the increasingly open hardware aspect of networking. While this topic alone could consume a half day of material, in the interest of being complete, I wanted to at least mention and touch on this part of OpenFlow. James Hamilton of Amazon frequently refers to current networking hardware as the new mainframe, making some fascinating comparisons of current network switch confinement and proprietary nature versus today's mainstream commodity x86 servers. And switching silicon has also begun to break free. Please note his diagram above clearly shows Broadcom and Marvell. That's a hint about the size of a bus. And a fascinatingly simple tier 1 naked switch. With the cover off, it's a bunch of connectors, it's a piece of silicon, and a whole bunch of fiberglass. Interesting. James's side-by-side comparison of chipset logic, hardware suppliers, system software, and the key notion of application stack are clearly summarized by his words, closed, proprietary, and confining. To my eye, the essence of what OpenFlow is enabling change and escape from this confinement. In addition to James' blog, luckily Cade Metz of Wired just posted this piece about Cumulus and Pica 8 back in March, so now I can actually talk about them. There's now lots more information becoming revealed around clever use of networking merchant silicon and how it is changing who now makes what, and a new emerging group of OpenSwitch creators. Cade states that Google, Amazon, Microsoft, and Facebook, probably others, buy more networking hardware than practically anybody else. But the point is they're buying less and less tier 1 gear and the rest of the world's, also from the rest of the world's large networking vendors. In contrast to purchases, God bless you. In contrast to purchases from traditional tier 1s, these firms are now leveraging their size and buying power and increasingly purchasing switches directly from the same Taiwanese and Chinese manufacturers, ironically also used by the traditional tier 1s. To my eye, this shift will lead to a major change in the overall networking market. Much like back in the 1990s, before I had wrinkles and gray hair, when the majority of enterprise computing was distributed Unix on platforms primarily proprietary Unix and RISC on Sun, HP, and IBM. Fast forward to today, this has massively shifted over to commodity x86 servers, also from tier 2 ODMs and integrators, running open source Linux and other open source software. The combination of these newly emerging non-tier 1 switch vendors with open source software and developer enabling SDN such as OpenFlow is also of potentially huge impact. From the enterprise point of view, massive CapEx and OpEx saves are enabled by this newly developing part of the networking marketplace and open source software, such as those software tools I mentioned prior, enabled by OpenFlow. Both are clearly on my disruptor innovation radar. Footnote: this is highly consistent with another recent blog post from Register.com back in January 2012. It was entitled, "Cloudy Servers Shoot to the Stratosphere, Rise of the ODMs." This blog post quotes iSupply analysts Peter Lin and Matthew Wilkins as tracking a huge shift of cloud server manufacturing towards non-tier 1 server contract manufacturers and integrators. Open Compute is probably one of the most open and well communicated in this regard, but there's a lot of others going on as well. It makes perfect sense that enterprise customers should also have both of these hardware shifts on their radar in order to be price competitive with external public clouds and enable competitive automation. So what if software-defined networks were thought of and measured similar to clouds? Exactly what would be most impactful and critical to measure? Back in 2011, in collaboration with Kyle Foster of Big Switch, he and I started with a version of my original cloud metrics sampler framework and tried to come up with 4 or 5 analogous categories for software-defined networking. How long does it take to create and implement a new tenant virtual network? How long does it take to move a guest OS VM among virtual networks? What's the overall flexibility of the network topology? How open and easy is access to the automation and developer tool interfaces? How open and language independent is that interface? How ergonomic and efficient is deploying the new software-defined networking-enabled applications? Excuse me. What is the diversity of open network switch vendors your software layer supports? Are the APIs universal and compatible across multiple merchant silicon? In a nutshell, we're throwing out this matrix as a straw man starting point. It would be great to collaborate with others around this. The real potential disruptor here is the impact of software-defined networks developer-based automation can have on dramatically improved enterprise operational efficiencies and OpEx reductions, which leads me to the next slide. This is another slide that could spend a half a day on. From an OpEx and CapEx perspective, what's the potential data center impact of increasing all this automation and reducing the CapEx? In a nutshell, The CapEx and OpEx impacts are huge via hardware standards, positive commoditization, and automation support. Very difficult to get industry colleagues at enterprise firms to disclose what their networking OpEx percentages and CapEx percentages are of their total IT budget. And not much in the public domain from places like Gartner, Forrester, and others. So in order to have a conversation around this, it's made some conservative assumptions. It's not hard to imagine some enterprises with a 20 to 30% of total CapEx and OpEx being targeted around networking. The bottom right of the slide here gives a list with some very interesting ranges for potential OpEx and CapEx save. This is very conservative. I can tell you from conversations with friends over meals and beverages and in flight, it's a lot worse. This could be a very, very awesome collaborative study or an open industry project via CIO and CTO survey, and as a result, we should publish. Okay. 40 minutes, sorry. We finally have the summary. A couple of closing thoughts. IT is too darn slow. Automation is the key. By the way, IT is too darn slow. Those aren't my words. Those are from the 3 CIOs that were quoted in Information Week. Some of them are starting to get this. OpenFlow is the first truly interesting, innovative, and disruptive networking idea in a very, very long time. OpenFlow, software-defined networking, and open source networking apps are potentially huge game changers and enablers. I'm very excited about it. OpenFlow is also enabling switch hardware standardization, open developer and automation. It's beginning to bridge that networking Grand Canyon. And connection and integration with current developer tools languages like Python, Java, Ruby, and others. Underlying supporting application server platforms and other things. These connect and enable multiplicative technology worlds for the first time. Networking infrastructure as code is a potential killer infrastructure app and platform. The potential CapEx and OpEx impacts are huge via hardware standards, positive commoditization, and automation support. They must also heavily collaborate and integrate with other open source projects. Just to pick off a few, Chef, OpenStack, and others. Could there be a creation of an open network compute similar to something like the Open Compute Foundation? How do we track the progress and adoption of the new emerging group of open switch hardware and software-defined based startups and leverage their automation and virtualization technologies to target significant CapEx and OpEx reductions? To the enterprise, security models must also be defined, implemented, and integrated. And last, we must clarify and improve OpenStack collaboration. I recommend don't complain about OpenFlow gaps, participate, and collaborate. 43 minutes. Sorry it took so long. I hope this was of interest and value to you folks. Look forward to talking to you. Thank you.